All right, so let's go over these dynamic settings a little bit just so you have an idea of how all this works together. So time scale is an interesting setting to get slow motion effects. Now, there's a difference between time scale and resimulation. So if, let's say, I love this simulation, I want this exact simulation the way it looks, I just want to slow it down twice. I would have to resimulate this to get this exact look. However, if I just want this to be happening slower, to basically create the illusion of slow motion, I can set the time scale to something like 0.5. And this way, basically, if I run the sim, you're gonna see that everything sort of happens at half the speed, right? So right now, this is a time scale 0.5, and it simply takes twice as long to get to where we were before. But it also tends to smooth out the detail in the fire a little bit. So sometimes if you lower the time scale, you might have to increase the resolution to get the same amount of detail. The cooling basically cools down the temperature over time. So if I make the cooling something like 0.2 and run the same, let's see what kind of effect that'll have. So basically what you should see is that the fire doesn't last as long. It basically dies off sooner. So I can make it 0.5 to make this more dramatic. And you can see that all of these flames up here are now killed and we're only getting the flames at the bottom here. So I'm gonna make that maybe 0.2 again. Smoke dissipation, maybe let's make that 0.5. So right now the smoke has no dissipation. It's just gonna keep on going and going and going. But if I give it some dissipation, we should see the smoke sort of fade out and disappear over time. All right, so I'm running the sim and you can see that with smoke dissipation of 0.5, the smoke up here is fading out and it's gonna be nothing in a few frames, while before it was this amount of thickness all the way through. So this is a pretty sensitive value. You can make it even something like, 0.85 and run the sim. And you should see all of this thin smoke basically disappear right away, and it is. And then all you're left with is just a little bit of smoke down here. So I'm gonna make that maybe 0.2 as well. Smoke buoyancy basically controls how heavy the smoke is. So if you were doing something like dry ice, you could set this to maybe something like -4. Let's make that pretty dramatic so you can see the effect. So it's kind of difficult to see because the temperature is still pushing the smoke up. So let's make this maybe something like -20 just to make the dramatic, and run the sim again. And here we go. So, at smoke buoyancy -20, we're getting everything is getting pushed down pretty dramatically. And the fuel buoyancy, we're not really emitting any fuel, so it won't have any effect right now, but this would control, again, you could make the fuel sort of go down if it's rising too fast. You can maybe set the fuel buoyancy something like 0.1 to keep it lower to the ground. All right, so the verticity controls the amount of swirls and the size of the swirls inside of the smoke, basically the little plumes and everything. So large scale, maybe we can make that all the way to 1. Let's make everything 1. It's difficult to see right now because we don't have a whole lot of resolution in the sim, but definitely, large scale 1 is something you would use for something like a volcano, and large scale 0.1 is something you could use for something like a small object on fire. So you can see that with all these settings cranked up, we're getting a different look of the fire. We're getting a lot of these little side swirls, all these little tiny plumes and everything. So the conservation is important. Usually you would raise the quality to something like 40, sometimes even 100, and you can change the conservation method. So usually PCG symmetric is the nicest one, but it takes the longest. Buffered is best for realistic small scale fire, and direct symmetric gives you good results and simulates pretty fast. That's why it's the default. But basically, if I had a bunch of objects in the way of the smoke, so if let's say I had a box here, and then I had another box here that the smoke has to float around, Sometimes the smoke can sort of lose speed and just sort of die off and it won't really continue, that would not happen in real life. So let me run the sim, show you what I mean. So right now the quality is already cranked up to 100. So we should basically see that as the smoke hits the block, it still maintains its energy and it's beautifully flowing around the box, and it's, continuing up, and it's behaving pretty realistically. We're getting some nice results. If the quality is really low, like maybe 5, you will see that the smoke is not that good at adhering to, the object's shape. The swirls aren't really there as detailed and stuff like that. So the quality is something that I would raise to something like 40, and I'll show you more examples later on. Steps per frame, you would want to do 2 for anything where there's a fast moving fire, or if, let's say, these boxes were animated to move through the smoke, you would need more steps per frame for Phoenix to be able to catch, the animation at every frame and adjust the simulation accordingly. We are gonna go over all of this in more detail in all of the exciting projects that are ahead of us. I just wanted to give you a brief introduction so you're not intimidated by these settings, and I'll see you in the next lesson.